Next, we'll take a look at z-scores. Z-scores are also called standardized scores, and they are another way to measure position. So the formula for z-score, first you need to find the mean of the complete data set and the standard deviation of that complete data set, and then define the z-score associated with any individual piece of data. You take that one score minus the mean and then divide that value by the standard deviation. And the z-score tells you how many standard deviations above or below the mean a specific score is. A positive z-score means it's above the mean, a negative z-score means it's below the mean. So if we go back to our example with Jenny, who scored an 86 on her test, and now I give you the additional information that her class average on that test was an 80 with a standard deviation of 6.07. So if we want to find her standardized score, we'll use the z-score formula, and we'll plug in her value minus the mean divided by the standard deviation, and she has a z-score of 0.99 or almost 1. So that means she scored about 1 standard deviation above the mean, or about 0.99 standard deviations above the mean. Next, we'll take a look at what happens when you transform data. Transforming data means that you either add, subtract, multiply, or divide all of the values in a data set by some certain value. Maybe if your teacher was going to curve a test score by giving every student in the class an extra 5 points, that would be an example of a transformation. So all of the test scores would go up 5 points each. Or maybe you used the wrong units in collecting data, and let's say you wanted to change from like inches to feet. So you would take all of the data values in your set that you had measured in inches, and you would divide them all by 12, and that would give you a new set of data. So these are examples of transforming data. And when you transform data, it changes the shape, center, and spread of the distribution. So specifically, if you add or subtract the same number or a constant from all of the data points, here's what happens. All of the measures of center or location also increase or decrease by that same constant. So the mean, the median, the quartiles, and percentiles, they all increase or decrease by whatever value you added or subtracted. However, the measures of spread or measures of variability, like the range, IQR, standard deviation, they all stay the same. So here is an example of what that might look like. So if we had, let's say this here was our original data, and here were the summary statistics of the original data, and then we took all of those values and we subtracted 13 from them. This is your new dot plot. So we just took all of those dots and we shifted them essentially down or to the left 13 units. And if you look at each of these summary statistics, you can see the mean also went down by 13. The minimum, the quartile, the median, the upper quartile, the maximum, those all went down by 13. Those were all measures of location, whereas standard deviation, IQR, and range, those are all measures of spread, and they've all stayed the same. Now let's see what would happen if we multiplied or divided all of those values in a data set by some constant. So if you multiply or divide all of the values in a data set by a constant, all of the measures of location and center change by that same value. So you'd multiply the original mean, median, quartiles by that constant. And this time, the measures of spread also change. They get multiplied by the absolute value of that constant. It does not change the overall shape. Neither of these do. So if you transform the data, if it used to be symmetric, it's still going to be symmetric. If it used to be skewed to the right, it will still be skewed to the right. So the shape is not changing. So here's an example where we changed the units to make it a little easier to understand. So maybe we're changing from meters to feet. And you can see the two sets of data here. And if we look at the measures of location, all of these measures of location are multiplied by the same constant as the original data. So 3.02 times 3.28 gives us 9.91, and so on for the rest of the measures of location. But this time, the measures of spread also get multiplied by that value. Whereas when we were adding or subtracting, the measures of spread stayed the same, while the measures of location changed.